Good afternoon, and welcome to today's Roads and Bridges webinar titled New Hydrodemolition Technology for Higher Quality Results and Productivity, sponsored by Aquajet. I'm Gavin Jenkins, Senior Managing Editor of Roads and Bridges with Endeavor Business Media. To begin, let me explain how you can participate in today's presentation. First, if you have any difficulties during today's session, please submit to the questions window and our technical experts will help you out. We recommend disabling any pop-up blocking software or extensions in your browser, as these can cause issues with the webinar player. Additionally, we welcome your questions during today's event. We will answer as many questions as possible during the Q&A session that will follow the main presentation, but please feel free to send in your questions at any time. To do so, simply type your questions into the question window on the side of your screen and hit the submit button. Also, please be aware that today's session is being recorded and will be available on the Roads and Bridges website within the next 24 hours. You'll be notified by email when the archive is available. Now, I would like to introduce you to our speakers for today's discussion. Keith Armishaw is the Business Development Manager for Aquajet's North American subsidiary. Before joining Aquajet in 2019, Armishaw amassed 24 years of industry experience with the brand as a service technician, service manager, and sales associate through a Quebec-based distributor. He works closely with the regional sales team to grow awareness of Aquajet's solutions and enhance customer support with industry-wide educational initiatives that increase understanding of the benefits of hydrodemolition. Ronnie Hilmerson leads the engineering and design at Aquajet. His responsibilities include software and product development, along with marketing. He invented much of the technology for Aquajet's product line, including the Ergo Compact Hydrodemolition robot, the control system for EcoClear water treatment system, EcoSilence high pressure pump, and the new Aqua Cutter 750V with infinity oscillation. He is the son of Aquajet founders Stefan and Marianne Hilmerson and joined the company full-time in 1999. Welcome, Keith. Please go ahead.
Well, hello, everybody. Thank you for joining us today for our webinar on new hydrodemolition technology. My name is Keith Armishaw. I'm the North American Business Development Manager for Aquajet. And I have my pleasure here to be with Mr. Ronnie Hilmerson, our Design and Development Manager. Ronnie works out of the head office in Holsbybrunn, Sweden. And he's here to share some insight into how hydrodemolition technology is developed, starting from feedback we get from our customers from all around the world and what they're seeing on these job sites all around the globe, to finding the best solutions for these problems. But first, I'd like to tell you a little bit about Aquajet, who we are. Aquajet's a company that was founded by Ronnie's parents. We've been manufacturing hydrodemolition equipment since 1988 and are known as the industry leader in hydrodemolition machines and solutions. We offer the most complete line of products, including robots, frames, high pressure pumps, water treatment system, and a full range of accessories that make it possible to remove concrete from virtually any part of a bridge. We're constantly innovating and refining our design to enhance the speed, to mechanize and increase safety for a variety of difficult applications, and to provide, precision and control for concrete removal. So why choose hydrodemolition? A couple of points I'd like to mention. One being the elimination of microcracks or microfractures. Some people call them microcracks that are created by mechanical tools that hit the concrete and leave a small crack in there. Since we're using water we don't have any, there's no mechanical impact. And so we reduce the amount of microfractures to a minimum. And what that does in return, it increases the bonding strength between the old surface and the new surface, the new layer of concrete that will be applied there. Another thing in regards to speed and productivity is we're 25 times faster than a handheld jackhammers. So you need very large crew to reach the capacity of a hydrodemolition robot. Another point that's crucial here is we strongly reduce the amount of silica dust exposure for workers on the job site. So since the whole surface is more or less wet and we're using water to remove the concrete, well, there's a reduction in silica dust exposure for workers. So the hydrodemolition method uses a high pressure water jet to remove concrete. As you can see here, we're using potable water, so water source is required. Water enters a high pressure pump unit. That's, you can see here. Once the water enters the high pressure pump, it's compressed to water pressures anywhere between 15,000 to 40,000 psi. Water is pushed out in a high pressure hose, reinforced hose, over to the robot. And the water enters the lance system, which you can see right here in the screen. And then we'll have a shot of the water jet exiting the lance. So what's happening here is the high pressure water jet is entering into small cracks and pores in the concrete and expanding it and breaking it, the material, while leaving the reinforcement steel intact. It basically looks like gravel. And we use lance angles up to 45 degrees to clean below the rebar to remove the shadows. Once that's done, the surface has to be cleaned, remove all the rubble, and then you're ready to pour a new layer of concrete over that. So earlier this year, Aquajet brought to the market a new patented hydrodemolition technology. Since it was released in January, several contractors in North America and Europe have put the technology to the test. As it was designed to do, the technology is helping them achieve a higher productivity, better results. And we refer to this technology as an infinity oscillation. So what we're looking at on the screen is a infinity symbol, and on the left of it you can see where the water or the symbol exits the lance. So the new lance motion we created is an infinity pattern, or it's like a figure 8. So here, Ronnie, hope you're doing well today. You doing okay?
Yes, thank you.
Excellent. So when you started developing this new technology, what problems were you looking or trying to solve, or what were you looking at? What brought you into to estimate, to reevaluate what you already had for the last 20 years?
Yeah, it was our customers or our clients were sometimes a little bit worried about those so-called pipe holes appearing in the hydrodemolition result. We could also see them, but only sometimes. Yeah, that's what we started to think about, how to address these problems with some technical solution. And also we were thinking about what actually caused them. We had some different theories, and all the customers had their theories.
So yeah, so a bunch from everyone's experience, and on the screen here we could see a little bit what we're talking about these pipe holes or pinholes, call them what you want, on the concrete surface.
Yeah.
Okay.
Yeah, and they in some cases you cannot see them, and some cases they are more visible. But our experience is that when the concrete is poor or soft, then they are appearing more than if the concrete is more fresh and harder.
Okay.
And
So what kind of problems can this cause? I mean, the concrete's still there. What problems could occur from that type of surface, from these holes?
Yeah, the problem is that when recasting, it's hard to get the new concrete into those pipe holes sometimes if they are too deep. And also it's harder to clean out the dust, the concrete dust from the bottom of the holes. And if there are air pockets left inside, or if there is dust inside of those holes, you will have a smaller bonding area.
It'll reduce the bonding, yes, between the two surfaces. Yeah. Okay.
Yes.
And is there a position that would occur more on? I mean, is it if it's working on, like we're talking about a bridge deck, if we're on a wall, or what is there an impact where that would be?
Yeah, you have the gravity problem that so if you have a bridge or a horizontal surface, then it's easier because then the new concrete will obviously go down to the pockets easier. But if you have a vertical or overhead, then it can be harder to really get the fresh concrete into the pipe holes.
Yes. Okay. I think that's what we've seen. We've got some similar feedback from some customers also. Okay.
Yes, and I can also say that there are factors that is making this more visible. As I told you, the quality of the concrete, of course, and then also the pressure, how much pressure you're using, the water pressure. Okay. So when using like a lower pressure and higher flow, then you have a much harder or more spread impact on the concrete.
Okay.
So that is making the pipe hole effect not so much. But if you have higher pressure and less flow and still the same power, then you have more like a precision water beam. So that is not so forgiving. So then the pipe holes will become more visible.
So maybe you can explain. Now we're gonna folks got to try to stick with us here a little bit. We're gonna go into some little technical details about what's happening on the equipment out in the market. We're talking about what we call our standard oscillation system. Maybe Ronnie, you can explain to us, because this is technology we've been using for the last 20, probably over 20 years right now, right? What we're going to show right here.
Yes.
And I can explain on our equipment.
We are.
Okay.
And it's a good system, but there is some things you have to take into the calculation when doing the work. Okay. So I can explain a little bit here. If we start with the vertical line with the 5 dots on it, that is representing the oscillation system when the carrier or the roller, as you call it, is standing still. Then we have like a pendulum. The lens is like a pendulum, and it will move forward and backwards, or in this case, in the picture, up and down. And what's driving this is a crankshaft. So it will have 2 dead centers in the end of this line. That is representing the red rings here.
Okay.
So as this excenter is moving, the speed inside the oscillation stroke is changing. So in the middle, the speed will be very high, and in the endpoints it will be 0. And somewhere in between there, it would be a good speed, what we call it. So when we're adding the sideways movement of the carrier or the roller, then this pendulum motion will translate into like a sine wave.
Okay.
So we can see there that on top at the red arrow, we will have a quite low speed. That will
Okay.
only be the speed of the carrier or the roller to the side.
Yes. Yes.
And then it accelerates down to arrow number 2, that is green, a speed in between somewhere. And in the middle at the 3, you will have the highest speed. So with our oscillation system, this speed in the middle can be up. It can be over 100 meters per minute.
So yeah, that's like 300 feet per minute.
Yeah.
That's very fast. Okay.
So that means that the speed will fluctuate or change between the speed of the roller and the maximum speed of the oscillation, simply talking.
And when we get to the bottom of the sine wave, that's another stop point, basically, and we start over.
Yes.
Okay.
Exactly.
Okay.
And the diagram on the right, that is the red and yellow and green diagram, that is something that we discovered, that the surface speed have a connection to the performance of the machine, or the hydrodemolition process. So we can see that at 0 surface speed, the performance will also be close to 0. And then as increasing the surface speed, the performance will go up quite fast to the green zone, or 100%. And it will be up there at 100% until a certain spot, and then it starts slowly to go down again. So that is also what those arrows in the sine wave are representing.
The best spot to remove the concrete at.
Yeah, and also what is happening in the red arrow is that because the lens is almost standing still, it will make this pipe hole there, and then as it accelerates, it will remove concrete, and then it will make another pipe hole in the bottom of the sine wave.
Okay.
So the pipe hole pattern often appears in arranged lines.
Okay, and that's what's treated by this oscillation system, where more or less where the speed comes back down to just the roller speed, or almost 0.
Yes.
Yeah. Okay.
It is created of the unconstant speed, and it doesn't only have to depend on the oscillation. It can also be that maybe the machine is unstable and is like shaking. Then the speed can also variate and create pipe holes. And in worst case, if the machine is vibrating or moving in the same frequency as the oscillation, then it can amplify this problem.
We got a quick shot here to see, just to show what it looks like in real life. So we can see the forward to back movement of the system. So that's where we would get those, potentially could get the pipe holes from that motion right there. Like I said a while ago, the equipment's been around for more than 20 years with this principle, and
yes.
I mean, it's being used all around the world, and it's not something that's been experienced everywhere. So
no, it's in some conditions it happens.
Yeah. So what can be done on job sites right now? Because I'm sure there's people on there questioning this. What can be done on job sites on an everyday basis to try to eliminate or limit the amount of these of this potential problem?
Yeah, as I said, the water pressure is a big factor. So the pipe hole problem becomes bigger or more probably to happen when using a higher water pressure. So using the same amount of power in the pump, you can go down in water pressure and up in flow, still have the same performance, but much more forgiving for creating pipe holes.
Okay.
So reducing water pressure will help the most.
Okay.
And there is also some settings on the machines you can play with. That is, the first is the oscillation speed. That will be the speed of this pendulum forward and backward. In the aqua cutter, it can be up to 360 RPM or strokes per minute. So when reducing that, then you will have a smaller difference between the speed changes. So the speed in the middle of this sine wave will be less or slower.
Okay.
So the fluctuation will be smaller.
Okay.
And the same applies to the oscillation stroke. So with a smaller stroke, obviously the speed in the middle of the sine wave will be also smaller.
Yep.
And
Okay.
the speed differences will be smaller.
Okay.
And one more thing to think about in the machine settings is the indexing distance. That is the distance that the machine is traversing forward or backward inside the sequence.
Yeah. Okay.
So that can be typically like 20 or 30 millimeters or one inch. And you have to make sure that those indexing distances does not line up with the oscillation distance, the oscillation stroke. So then if they line up, then those points where the speed is lowest can align with each other and amplify each other.
Yes. You've seen that before. And I think you got one more here that what's the lance attack angle?
Yeah, the lance attack angle is how much the lance is leaning sideways. It can be up to 45 degrees. And when leaning the lance, then the pipe hole effect will become smaller. That's also why there is an option to have different lance angles inside the same sequence. So it can go down to the working depth really quick by having a smaller angle, and then you can have a bigger angle to clean out and polish the surface,
to make it look
clean out the surface.
Yeah, like on the image we're looking at right now.
Yes.
Okay, well that makes sense. And we've seen that experienced operators and contractors are able to give good work just the same with the equipment. There's no doubt about it, because we've seen a lot over 20 years. So it's thank you for bringing that for clearing this up. So now I guess let's talk about this new technology. So what does it do, and how is it different from the standard system that we just looked at?
Yeah, what we started to think about when we developed this new system was how to address this problem, or what you call it, that the speed is lower in the ends of the outer areas of this sine wave. And what we came up with is a solution that is turning or moving the lance like in a figure 8 pattern. So what we're actually doing here is, if we start again here at the left side of the picture, at 1, we are adding a movement in the same direction as the roller is moving, or the power head. And thereby we eliminate this problem with that the lance is standing still. And if we proceed down at the number 2, that speed will be the same as it would have been in the sine wave. And at number 3, we are moving the lance in the opposite direction of what the roller is moving. So there we are actually subtracting a little bit of speed.
Okay, so it makes sense.
Yeah, so this is meaning that when you're moving the roller sideways at the same time as doing this figure 8 motion, you will have this like overlaying pattern you can see in the bottom of the screen. And that also means that if we're looking at the diagram again, that the surface speed can be constant up in the green zone. And that is meaning that the performance will also be constant in the complete oscillation stroke.
Okay. So where we had a problem with speed being too low and too high, we came up with a solution to speed it up in that area and slow it down in the opposite one. So we're able to maintain the speed across the surface at a more equal speed.
Yes. So when those settings are matched with each other, the oscillation stroke, sideways and longitudinal, and the speed of the roller, you will have a totally constant speed over the surface.
Okay.
And the machine is helping you with that to get the correct settings.
Okay. So you can see it here, how the motion, what it looks like. So let's see, maybe run here a couple of results. Maybe you can show us what came up here on these. Maybe you can explain this test or what we're looking at right now.
Yeah, I can. The left picture is the surface after removing with the infinity oscillation. This was done with 2,500 bar and a quite low flow.
So that's the 36,000 psi. Yes. Okay.
Yeah, and we can see that there is no pipe holes there.
Mm-hmm.
And we can also see in the right picture that this is like a deep cutting, and we can see that this system is digging very steeply in the side without creating any pipe holes there either.
Okay. And here we can see, maybe you can just explain this one also, but what we're looking at there.
Yes, the one to the left is with the standard oscillation with the sine wave. And we can see that if we are looking closely to the picture, we can see that there is some pipe holes aligned in, they are in like horizontal lines, and you can see them appearing with a constant distance between each other.
Mm-hmm.
And that will be where this sine wave is turning. And in the right picture, you have with the exact same settings and the same high pressure pump with this new movement added when the lens is moving in the figure 8, and the surface speed is constant. And we can see that those holes are not there anymore.
Okay.
So what we're doing here is that we do not have to like compromise with any settings. You can use the optimal settings to get a good result, and still don't have to worry about having to do anything to get rid of the pipe holes.
Okay. So someone who was used to using the standard system could, probably get very good results with the new Infinity system.
Yes.
Beyond, making this easier, I guess, you were looking at the solution for the pipe holes. Well, what else did you discover anything else? Once you got that system figured out, anything else come to mind that made a difference also?
Yeah, you could call it like a side effect of this is
Okay.
because we are optimizing the surface speed all the time to be constant, and we discover that the surface speed is connected to the performance. We can do now with the Infinity system, instead of with the standard system, you would sliding back and forth on this curve. So you will alternate between like say you go between 20 or 15 meters per minute in surface speed, and in the middle of the stroke you would be up to 100. Then you would go back and forth on this curve all the time when the lance is oscillating. So sometimes the performance will be like 80, and sometimes it will be 100, and then back to 80 again. 360 times per minute. But with the new system, you can optimize it so you are always up in the green zone. So you are constantly, for example, 50 meters per minute or 60. And there we also have the highest performance.
Okay, so did you note a higher removal rate, like when you're moving concrete with same pressures and flow as you had on the previous system?
Yeah, we have seen that it can go up quite significant in some cases.
Okay.
The performance.
Okay. And any other results that that were noticeable once because we did get some feedback from customers with this also. So what, in general, there any other experience, anything else you experienced?
Yeah, we have also seen that the shadows on the rebars, the shadows that is going along with the machine, same direction as the machine is moving, those we are addressing with the lance angle. But the other rebars that is going in the same direction as the roller movement, those one can be a little bit harder to get the shadows out from. So we have discovered that with the Infinity system, the lance is doing more work while it's at what do you call it? Its endpoint or in the ends of the oscillation.
True. Yeah.
It is doing work instead of just standing still.
Okay.
So that is why we are seeing that it's removing the shadows a little bit better than the standard system.
And at the same time, removing more concrete, so getting better productivity with the same machine.
Yeah.
Okay. And I heard you mention a while ago that it seemed to have a very good digging power. So with similar settings, would you say that it also would dig deeper?
Yeah, that is also the same reason. It is doing more, the water beam or the lance is doing more work while it's at the endpoints of this oscillation, the top and the bottom of this sine wave or the new figure 8 wave.
Okay.
So it is doing more work at the whole oscillation stroke.
You know, something that it's hard to, I guess I'll bring this up. It's hard to understand, but we're talking here of fractions of seconds, correct? I mean, we're only talking here of probably milliseconds, but when you have so much energy pointing in one direction, it makes a big difference. Yeah,
it's milliseconds because it can be up to 360 strokes per minute. So. But every time every millisecond will count in the performance.
Yeah. And that millisecond of the water jet just staying in one position is enough to dig a little deeper than where it was before as it was moving.
Yes, dig a little deeper, and it is spending quite a lot of time there also. So even if it may go a little deeper there, it is spending more time there than doing work there.
Okay.
So you're losing hydrodemolition time, but you are still like digging a little hole.
Okay, excellent. So maybe some feedback I know we have from some customers. We've seen some gains from 15% and over with this technology. So thank you, Ronnie, for explaining this to us. I hope everyone got a little bit out of that. And what we always we like to do is to show a little bit about some projects that have been happening across North America over the last year. So the first case study we have is a project in the Fort McHenry Tunnel in Baltimore, Maryland. Work is being performed by a contractor called Aquajet. And this contract consists of replacing a 15 kV conduit and cables and repairing unsound concrete in the ventilation plenum below the roadway in the Fort McHenry Tunnel. Hydrodemolition was specified due to reduce dust creation. So it involves cutting a 4-mile trench in sound concrete, so roughly 80,000 cubic feet of concrete needs to be removed. In the image, what we're looking at is once the equipment is mobilized. So this work is being performed only at night. So the operator, the team moves in at the end of the day after the tunnel's been closed and equipment is set up. What we're looking at is the water treatment system. The next vehicle behind it on the right is the water tanker, then the pumps, and then accessories that follow behind. And this equipment is set up like that and taken down and like set up in the morning and taken down at night, and like that continuously day after day. So a lot of mob and demob for this project. Take a little look at the equipment. So they're using our Aquacutter 410A series robot, which is a small electric robot, and our EcoClear water treatment system. You can see on the right image the robot working, and you can see the old conduits being exposed after the hydrodemolition. And the depth of removal is anywhere between, if I remember correctly, from 14 to 16 inches deep to expose the conduits. And I think they're at least 4 inches in diameter each. And the EcoClear water is pumped from below and sent up to the EcoClear treated. And they're actually reusing the water. So they expected to use more water, up to 5 or 6 tankers per shift. And with the closed loop system and EcoClear, they're using 1 tanker per shift. So that big savings in regards to water management for the Aquajet team. And so here's a shot from inside the tunnel. Again, we can see after they've removed the rebar and the conduits, what's left behind. So that surface has to be prepped, the new rebar added, and the new conduits put in place to be able to put concrete over it. And if I'm not mistaken, it's going to be repaired by shotcrete. So some of the challenges on this project was, well, obviously confined space. I think it was about 6 foot tall in the center there. The environment requirements, for collecting water and treating the water. Also, the environment being very windy in there because it is a ventilation area, so there's wind blowing constantly. So the workers are put through tough conditions. Also, night work. Lane closures, no real water source, so water had to be trucked in, and the whole operation had to be 100% mobile to be able to move things in and out of the tunnel quickly, so we're not wasting production time on mobilizing. And here we have a shot showing, once the repair is completed, like the pipes are put in position, the rebar is in position. So that gives you a little look of what that looks like. So congratulations to Aquajet on a job well done. It's looking good. Next project we have, or case study, is actually done in the Midwest. Contractor here on the hydrodemolition is Beartooth Water Jetting. These projects involved surface milling. So the concrete was removed with the milling machine from the surface of the bridge deck and down to close to the rebar, about 2 inches, and then hydrodemolition needed to be performed to a depth of 3 inches. So for like a total removal of 5 inches. We have a shot showing the robot in action. And on the right-hand side, we can see they were using a vacuum truck to clean, and on the close to the image, closest to us is the high-pressure pump system, and far away past the vacuum truck is where the robot is. So the surface was being cleaned as the robot was producing. And in this case, Beartooth was using our Aquacutter 750V with the infinity oscillation system. You can see some of the results he got look pretty good on the surface using the new oscillation system. And project seemed to be successful. So thanks to Beartooth for sharing this information with us. Next case study we have is a project up in Quebec, the province of Quebec, Canada. The project is on the Dubuque Bridge, which is over the Saguenay River. And the contractor here is Paul Pedneau, contractor, been in business for almost 50 years. So they finally got into using hydrodemolition equipment on one of their first bridge projects this year. This bridge was built in the 70s, early 70s, and it has a span of about 458 meters. And the contract consisted of removing the center jersey, so the center barrier between the north and southbound lanes, and to rebuild that jersey and do some concrete repair in the two center lanes next to the jersey barrier. So first process was to remove the asphalt. When removing the asphalt, they scraped it off. So what happened is they exposed what you see on the center image and the left image is like a tar from the rubber membrane that was stuck to the surface. So once they tore that off, they needed a method to clean it, to remove it, to be able to inspect the bridge deck properly and do their chain drag, so that they could find any weak spots in the concrete. So they used our Aquacutter 410 and a Rotoland system, and we're able to clean the surface just lightly, just to remove the tar that was stuck, or the rubber membrane that was just stuck there, and expose all the surface. So that was pretty good for them to use that equipment. Once that was done, the equipment was moved in with the straight cutting head, and then, as you see on the right image, we're able to remove the concrete below the rebar, exposing, removing all the shadows, and that's where the new jersey barrier was going to be installed. The water was captured there and pumped off the bridge, and Paul Pedneau had a water treatment system set up there to treat the water for pH and high turbidity levels, and then it was being discharged. So nice work to their team on that project. That project's now completed, paved, and so then our last case study here is with on an overpass on the Royal Avenue, which is next to, which is real close to the Patello Bridge, which is being, I think it's a new bridge being installed there, and there's some work to be done on the roadway, and there was some upgrades needed to be done to this overpass. So Walco Industries was hired as a hydrodemolition contractor to remove the concrete on the abutment walls. So what we see in the image now is where the hydrodemolition work was to be performed on the left side, and you can see on the right side of the image, on the right abutment wall there, more or less what it looked like. So the whole area was closed off to protect ongoing live traffic. As you can see where the jersey barriers are, the traffic was right there. So that was enclosed to protect them, and also to protect the people on the job. So they used our Aquacutter 710V robot, and you can see how the height we had to go. So the height was up to 20 feet in the air. In the center image, you can see how the contractor excavated down to the footing, the foundation of the abutment wall, and work started at the bottom and was worked up. You can see on the right-hand side, the operator, just maneuvering the machine into position. And on the left-hand side, we have the results from the hydrodemolition removal. So this whole abutment wall was done in, there's setup time required, but once it was set up, probably like a 2-day job to do the abutment wall. Water was collected there and pumped just off the overpass a few hundred meters away for treatment. So nice work, Walco, on this job. And again, showing flexibility of equipment and different areas that hydrodemolition can be used on for road and bridge work. That's the end. That leads us to the end of this webinar. I'd like to thank Roads and Bridge for giving us this opportunity. Thank also our customers who participated, Crazynet, Beartooth Water Jetting, Pulpendo, and Walco Industries, and also a big thank you to my colleague and friend Ronnie Hilmerson, and thanks for sharing. Thanks for sharing your hydrodemolition knowledge with us and experience. Very appreciated. I hope people were able to get something out of all that. Thank you.
To both of you. Some of you have already submitted some questions, so we're going to jump right in. As a reminder, if you would like to submit a question, type your question into the window on the side of the screen and hit the submit button. And now to jump into these Q&As, the first one is, does the new technology take more water?
I can answer that. No, with the same conditions, it will not do that, because you can use a lower flow and a higher pressure with water. So then you are using actually less water, and also because the new technology is more efficient, you will remove more cubic meters per hour with the same amount of pump power. So you can actually, if you want to use remove exactly the same amount of material, you can actually decrease the pump flow a little bit.
Okay. Next question. Can Aquajet be utilized at isolated locations where there are issues with new concrete construction where voids are identified?
I'll take that one, Ronnie. So, yes, it can be. The machine can be used to remove concrete if there are voids that are identified to dig out that area. Yes, it can.
Okay. All right.
So the answer is yes. If it's worthwhile to mobilize, that's the question. To mobilize equipment like that for work, I guess the machine, yes, the machine can do it. Now, is it worthwhile to mobilize that equipment depending on the volume that you have to remove in that area? So if you're going in for 10 square feet, maybe not a good mobilization, like a very high cost for that. But if you have like a lot of volume to do, then it is definitely worthwhile having the equipment for that.
Okay, fair enough. Our next question, how do you mitigate the environmental impacts? Particularly, the water used for hydroblasting will be very high in pH. It will be difficult to capture all the water and preventing it from running off the work area, especially if you punch through the bridge deck over a river or waterway. Who wants to jump in on that one?
I'll dive in on that one a little bit. I'll blow through the deck. So, yes, typical pH levels from our hydrodemolition operations that we see from our customers, anywhere from 9 up to 12 as a pH level. And there's always the risk of blow-throughs. And yes, sometimes you may be over water stream. So I guess it's a calculated risk that needs to be taken. And most contractors who are doing the work today are very aware of that. And intervention plans are made to stop work immediately and to plug holes to limit the amount of water that could be going over there. So, I mean, we're not talking about huge volumes of water. It's a question of how the job is set up. But contractors are on many sites now are very familiar with that typical problem that can happen, especially if you're going, very deep removal, like if you're moving 5 over half, like if the bridge deck is 8 inches and you're moving 5 inches or 6 inches of it, well, there's not much left on the other side to protect. So there's always a higher risk of a blow through. And then contractors are aware of that, so they're either try to identify areas, they can reduce pressure, and they can contain they can channel their water better so that they limit the amount of water that could go through in that area. So keeping a clean job site is key to that also.
Okay. How is your equipment different from other equipment available on the market?
Ronnie, maybe you take that one.
Yeah, I can take that. I would say that we focus a lot on user friendliness on our equipment, and also on efficiency. So, for example, we have the same type of control system, or our own developed control system on both the robots, the pumps, and the water filtration system. So the operator can easily recognize between them. And also we have worked a lot with the servicing on the machine. So you can, for example, open up the aqua cutter fully and reach every part inside very easily. And for the efficiency side, we have a lot of inventions like the EDS system, where we keep the nozzle very close to the concrete surface. And we have also of course the Infinity system we talked about today. And we have the Smart Land system, that is a software thing that is controlling all of the moving parts of the machine in the automatics in a very precise way. The machines are very stable to create a good result and to be also effective because of that. And we can recycle the water with the EcoClear back to the pump again. So both the water consumption and also for the environment is good. And our pumps, we have worked the EcoSilence pumps. We worked a lot with both fuel consumption. We have the auto start and stop, and we have also low fuel,
noise reduction.
Noise reduction. Yes. So I think that's what differs our equipment from others.
Okay. All right. What is the advantage of rotary head versus oscillation? Do Aquajet machines have rotary head capability? My state's specification requires rotary head for the final pass of the machine.
Ronnie, maybe you can answer the first part.
Yeah, there is some benefits of it. You will you can be almost sure to have a very good result, a very smooth result. But the downside of a rotary head is that it's almost always lower performance than an oscillating system will be. And sometimes, depth-wise, cubic meters or cubic feet per hour. And I would also say that it's harder to get the shadows out from under the rebars with a rotary head.
Yeah, And and we do have a rotary tool that can be remounted if we have to do a final pass with a rotary head. We have that. So it's called a rotolant system. So if there's a final pass required, we do have that.
Yeah.
Okay. This comes from a DOT. How do states spec the infinity oscillation to make sure they get the right equipment?
That's a good question. How do they spec it? I guess we would have to supply some kind of a specification for it in to explain what it does in regards to the motion, so that they could, if that's what they're looking for. So it's more or less just by using the terminology, because it is a patented movement that we have. So by using that terminology, it should be our system.
Okay.
Yep. But they can reach out to us also, and we can just talk and see what's the easier way to use that, or get similar things also that you're not shortening the number of customers you can work with also.
Okay. All right. We already asked that. I'm sorry. How do you control depth of demolition?
Ronnie?
Yeah, the depth is controlled. Actually, it's all about exposure time. So you can control that in several ways on the machine. It's the number of traverses, how many times the power head will go forward and backwards on the feed beam. And it's also, of course, the traverse speed of the power head, and how long the distance the machine is indexing in every cycle. And you can play with those settings to get a good balance between them to get a good performance. And on top of that, you can add this optimization of the lance angle and the oscillation to have a better performance factor. But it's mostly all about the exposure time, how long time the machine is on each surface area.
Okay. This next question is about the graph that you showed in the presentation, and it says it asks how did you quantify performance in this graph? Is that too vague, or do you know what the question refers to?
I'm not sure what the question means, but I can tell you that we did a lot of tests where we did it with very clean settings. So we excluded like lance angle and oscillation. Mm-hmm. And then we started from zero, letting the lance standing completely still, and then we increase the speed of the surface speed more and more, and we measured all the way up to 160 in this diagram, and we could see that it went up pretty fast, and then it started to go down again slowly. And about the percent value or the performance factor, that's just the percent value of what we were measuring at the maximum of those tests. So it's not a specific amount of cubic meters per hour.
Okay.
So and this is in this diagram is just an example. So it doesn't have to be exactly those figures or those numbers in every situation, so that can change, but our experience is that the curve will look like that, but it can be in different spots or different surface speeds.
All right. Pardon me. Can you say more about how to deal with the water?
Well, many states, are looking for. Every state and our province has regulations on water and water discharge. So contractors are already collect water. And like I mentioned a while ago, they're treating, with hydrodemolition blast water, pH levels from, 9 to 12, and normally have to get that back down to more natural value around 7 or 8. And then the turbidity level is very high because we have a lot of fines that are carried away in the water, because we're rapidly eroding the concrete surface, breaking it into small particles. So that a lot of those fine materials, whether it be silt, sand, cement fines, are being carried away, and they get caught up in the water. So so the total suspended solids there could be normally very high, anywhere from, and I'll give it this in metric values, but anywhere from 5,000 to 20,000 milligrams per liter of fines. So we need to collect those and bring that back down to a more standard value, to the appropriate value to be able to be discharged. Mm-hmm. And so that's how the water has to be treated. And the collection is something that's done by the contractors on site, and they're usually very good at figuring out ways to collect the water efficiently.
All right. Well, I'm afraid we've run out of time, and we had a lot of questions left over. Thank you so much for everyone who asked a question. If we didn't get to your question, we will be answering them via email offline. That concludes today's presentation. On behalf of Roads and Bridges, I'd like to thank Aquajet for sponsoring today's webinar. And I'd like to thank our speakers for their presentation. And of course, I'd like to thank all of you for joining us. Have a great rest of your day.
Thank you.
Thank you, guys.
Thank you.